October 21st, 2025. The new infrared data came in just before dawn. Observatories in Chile, Hawaii and Spain recorded something no one expected to see this early. A patterned sequence of infrared reflections from inside 3I Atlas. For months, this object has been tracked with growing unease. It's big, it's fast, and it behaves like nothing in the catalogue of known interstellar bodies. But this new data pierces deeper than surface anomalies. For the first time, we are looking beneath its shell, and what's emerging is not random mineral layering or fragmented core echoes. It's a structure, ordered, repeating, and dynamic. These readings are precise. The infrared peaks align at fixed intervals, shifting not like geological convection, but like something adjusting itself from within. In the language of astrophysics, this is not noise, it's signal. Something inside 3I Atlas is changing, in a way that implies intent. For a decade, scientists have speculated about interstellar probes that could passively traverse star systems, silent and undetected. Now, for the first time, a candidate isn't just on paper, it's in front of the Sun, and the timing is no coincidence. In just over a week, on October 29th, 3I Atlas reaches perihelion, its closest point to the Sun, and vanishes behind solar glare. For ground-based observatories, it will effectively disappear, a perfect blind spot. And just before it enters that window, the readings show movement inside. This isn't just another comet flyby. This could be the moment something dormant for centuries, maybe millennia, turns itself on. The first alert came at 3:17 UTC on October 21st, 2025. The data stream from the high-resolution infrared spectrograph at European Southern Observatory began to show an unexpected periodic modulation in the thermal emissions coming from 3I Atlas. At first, the shift was dismissed as an instrumental glitch. Transient spikes sometimes occur when tracking a fast-moving object against the early morning sky. But the modulation didn't vanish. It repeated with clockwork precision over and over for nearly 7 hours. By the time independent teams in Hawaii and the Canary Islands confirmed the pattern, the realization had already begun to sink in. This wasn't noise. This was coming from inside the object. Infrared spectroscopy doesn't see surfaces. It sees heat signatures and their distribution. When an asteroid or comet tumbles through sunlight, its thermal map shifts chaotically. Different patches heat up, cool down, or reflect radiation depending on their composition and angle. Natural bodies show irregular, noisy curves. What was recorded on October 21st was the opposite. The thermal flux oscillated in evenly spaced intervals of 43 seconds, repeated exactly 586 times before the signal faded below atmospheric thresholds. That degree of temporal coherence is almost unheard of in natural objects of this size. It implies something structured, something that's controlling or modulating its heat output internally. By dawn, analysts had already overlaid the infrared data with the object's rotational phase. The 43-second pulses weren't aligned with the spin of 3I Atlas. They weren't surface effects. They came from within. The peaks were also spatially clustered, indicating roughly 3 active interior regions, spaced evenly along its longitudinal axis. Those positions corresponded to areas that had previously shown anomalously low radar reflectivity. Back then, the gaps were dismissed as composition gradients or empty voids. Now, with the thermal data, they looked less like voids and more like chambers. The timing is what made it impossible to ignore. Just 8 days before the perihelion, the object begins to radiate in a coherent pattern. For months, 3I Atlas has been a silent intruder. No radio signals, no visible flashes, no obvious jets. Its behaviour was strange but contained. Now, right as it approaches the Sun, it starts talking in infrared. The pattern itself is subtle but layered. First-order modulation gives the 43-second pulse. Second-order shifts appear over roughly 11 minutes, as if multiple emitters were synchronizing and desynchronizing over time. Natural geological processes, such as sublimation or internal cracking, don't operate on clean periodic scales like this. To produce a pulse that regular, you'd need either a rotating mechanical system or a deliberately controlled energy release. Some researchers liken the signal to what you'd expect if large interior radiators or vents were opening and closing in timed cycles, like a spacecraft adjusting its internal temperature or pressure as it nears a critical phase. This isn't the first anomaly associated with 3I Atlas. Its deceleration in late September already hinted at something non-ballistic, as if the object applied a small but measurable force counter to its inbound trajectory. Its mass-to-size ratio remains inconsistent with a simple, rocky or icy nucleus. And now, with these interior emissions, the puzzle is no longer about whether it's just a weird rock, it's about what kind of system we're dealing with. Astronomers quickly coordinated a follow-up campaign. Infrared instruments at NASA Infrared Telescope Facility and European Space Agency orbiters were tasked with rechecking the signal every 6 hours, hoping to catch another cycle. But the emission pattern went dark less than a day after it began. Whatever triggered it, it was deliberate and brief. Like a diagnostic sequence, not a continuous process. The short duration raised more questions. If this were geological, there's no reason the emission would cease so cleanly. A crack-venting, volatile gas would show a decay curve, not a hard cut-off. A subsurface ice pocket would sputter as it sublimated, but it wouldn't do it with synchronized 43-second precision, and it certainly wouldn't stop mid-rotation, as if someone had flipped a switch. This was more consistent with a timed activation, or calibration, as if the object were preparing itself for the next stage of its flight. And that brings the story to the most critical factor of all, the calendar. October 29th marks perihelion, the moment the object slides behind the Sun from Earth's perspective. For several weeks, it will be in the solar blind spot, unreachable by most optical and infrared instruments. It will be the perfect window for it to do anything without immediate detection, adjust trajectory, release payloads, or remain dormant again until it emerges in December. The fact that the first interior signal appeared 8 days before this window isn't viewed as random. It's viewed as staging. Independent analysts, some from government space agencies, others from university research groups and private deep sky networks, began mapping the infrared signature onto existing models of artificial interstellar probes. One hypothesis that's resurfaced is the von Neumann probe model. Autonomous, long-duration machines that can self-repair, replicate, or deploy secondary assets once reaching a star system. If 3i Atlas fits even part of that profile, the infrared pulses might be part of an internal awakening process, systems powering up after centuries or millennia of hibernation. Skeptics have been quick to point out the danger of overinterpretation. Infrared anomalies have been misread before. Unusual rotation or hollow interiors don't prove technology, but what's different now is the convergence of multiple red flags, the unnatural deceleration, the extremely low effective mass, the rotational stability, and now timed emissions. A single anomaly can be explained away. 4, stacked in sequence, are harder to dismiss as coincidence. The internal structure itself remains invisible, only inferred through these emissions and radar echoes. But when analysts plotted the pulse loci along the object's axis, they formed an almost perfectly symmetrical triad. Natural voids inside comets are usually chaotic, formed by uneven sublimation or fragment impacts. This looks arranged. Even the slight phase shift between the 3 emission zones was consistent over the 7 hours, as if they were coordinated by a shared system clock. Nothing about that aligns with known geology. In private briefings, some astrophysicists have begun using more direct language. They no longer describe 3i Atlas as a comet-like body. They refer to it as an unclassified interstellar object with structural interior organization. That phrase may sound clinical, but it marks a profound shift. It means that, at least internally, some research groups now treat it less like an asteroid and more like an engineered artifact. The global response is uneven. Official channels, including NASA and European Space Agency, maintain cautious statements, focusing on unusual thermal behavior of uncertain origin. But in parallel, coordinated observation networks have quietly extended tracking windows and reallocated telescope time. Several assets originally scheduled for exoplanet transits have been reassigned to 3i Atlas monitoring, especially during its solar ingress. That kind of behind-the-scenes maneuver usually happens when agencies believe the event could escalate in significance. What's especially troubling is what happens next. Once the object moves behind the Sun, Earth-based observatories lose their direct line of sight. Only heliocentric probes can maintain partial coverage, and even then, with limited resolution. If this is a natural body, we'll just have to wait and see what comes out on the other side. But if it isn't, this is the moment when it can do whatever it was built to do. No telescope on Earth will see it. The infrared window of October 21st is now archived in multiple independent datasets. Analysts are working around the clock to deconvolve the signal, searching for patterns, ratios, or encoded information. So far, nothing resembles a message in any conventional sense, but the rhythm itself, the structured timing, is message enough. It says, something is inside, and it's moving, and it's happening just as the object approaches its only guaranteed period of unobservability. This is the line that separates speculation from unease. A geological oddity can be explained eventually. A timed, structured, synchronized thermal emission on the eve of a solar disappearance is something else entirely. Whatever happens behind the sun will either confirm this as a peculiar rock, or the first active interstellar artifact humanity has ever encountered. But the infrared signal is only the first piece of the puzzle. When scientists began correlating it with radar and light curve data, another anomaly emerged, one that goes to the heart of what 3i Atlas actually is. That's where this story deepens. The morning of October 22, 2025 began with a quiet but decisive shift in how analysts described 3i Atlas. The overnight processing of the previous day's infrared readings had produced something that no one expected to see so cleanly: geometry. Not chaotic, irregular thermal scatter, not fractured cores or jagged interiors. A pattern, aligned, repeated, and mathematically consistent. When the signal was first captured, it appeared as 3 hot zones pulsing along the longitudinal axis of the object. But after 24 hours of data integration and phase correction, what emerged was a clear internal lattice, a structured alignment inside a body that, by every public description, is supposed to be a tumbling interstellar comet. The precision of the geometry startled even the skeptics. The 3 emission zones weren't just aligned, they were equidistant along the spine of the object, separated by nearly identical intervals of 78 meters. The error margin on those intervals is less than 1.3 meters. No natural voids or gas pockets are known to form with that kind of uniformity at that scale. In geophysics, nature is messy. In engineering, it's precise. This was precise. The team at European Space Agency used layered radar tomography to cross-verify the thermal pulse locations. The reflection data matched the infrared signature perfectly. Each emission zone corresponded to a region of low radar albedo, almost like hollow or less dense areas. If this were a typical interstellar body, these would be irregular caverns or cracks. Instead, they appear as cylindrical cavities, their alignment almost mechanical. The shape resembles a central axis tube with evenly distributed internal chambers, something that looks suspiciously like a segmented internal frame rather than a natural fracture. By noon, several independent research nodes confirmed the symmetry. What shocked many is how clean the signal remained even under different modelling conditions. Usually when dealing with radar and infrared overlays, noise creeps in. Scattering angles distort the geometry, but here, even when correcting for the object's high velocity and spin, the geometry held its structure. This is not how random rock behaves after drifting through interstellar space for millions of years. The symmetry is also aligned with the object's rotation vector. 3i Atlas rotates every 8.7 hours, a stability that has baffled analysts since the first measurements in August. Its axis hasn't wobbled or precessed the way most long-travelling objects do. Now, with the interior map partially revealed, it's becoming clearer why. The internal structure may act like a stabilising spine, distributing momentum evenly, resisting external torques from solar wind and gravitational gradients. A natural body that big, with such a low mass, should have tumbled long ago. It hasn't. This isn't drift, it's control. An independent group of orbital dynamicists published a preliminary model suggesting that the internal pattern could support active stabilisation. If the cavities contain either denser material or active components, small energy adjustments inside could keep the entire body balanced through gyroscopic precision. That would explain why, even as it decelerated slightly in late September, the spin remained perfectly stable. There was no rotational drift. It was like watching a machine correct itself. This brings the discussion to the geometry itself. The thermal signature hints at 3 cavities, but the resonance of the radar returns suggests secondary structures branching out from the central axis. Smaller, evenly distributed extensions, each about 20 meters long. The pattern resembles what engineers call a truss or reinforcement skeleton, something designed to maintain rigidity during stress events. Why does this matter? Because the most extreme stresses are about to occur. Perihelion is days away. The object will be bombarded by intense solar radiation, subjected to rapid thermal expansion, and experience acceleration gradients from its curved trajectory. If this is just a comet, it could fragment under that pressure. If it's engineered, this might be the moment the structure does what it was built to do. In previous anomalous objects like Oumuamua in 2017, geometric modelling remained largely speculative. Data was fragmentary, signals were weak, and the timeline was short. With 3i Atlas, the signal is strong and sustained. This is the first time researchers can actually map part of the interior while the object is still inbound. At 1740 UTC, the team at NASA Jet Propulsion Laboratory released an internal memo outlining their findings. It wasn't meant for the public, but leaks are common in situations like this. The memo described the internal pattern as structurally ordered and incompatible with expected cometary cavity formation models. One particularly unsettling line in the memo stood out. The object's interior symmetry is suggestive of deliberate design or unknown high-order geological processes not previously observed. In plain language, they were admitting what many had already begun to suspect. This doesn't look like nature. Skeptics immediately raised counterpoints. Symmetry, they argue, can appear in nature through crystallization or slow accretion. Some metallic asteroids have evenly spaced layering patterns, and certain cometary nuclei show partially aligned voids. But none match the precision here. Even the most regular natural bodies degrade over interstellar travel. Tiny collisions, thermal cycling, and erosion erase symmetry over time. 3i Atlas appears preserved. As if the geometry hasn't suffered random impacts at all, that's where probability comes in. Statistically, the chance of finding an object with this level of symmetry, this stability, and this timing is extraordinarily low. Models run by orbital dynamicists place the likelihood of a purely natural explanation, involving no artificial stabilization, at less than 0.004%. That doesn't prove anything by itself, but it moves the discussion from coincidence to pattern-demanding explanation. The alignment of the cavities also matches something unexpected: the direction of travel. If you extend the central axis into its trajectory, the cavities are positioned exactly where they would be if they were part of a propulsion or deployment system, not random interior voids. It's like finding a series of aligned ports on the underside of an airplane wing and calling them natural cracks. It's technically possible, but increasingly implausible. Meanwhile, thermal imaging has continued intermittently. Since the initial burst of activity on October 21st, the emission has remained mostly silent, but brief flashes have reappeared during specific rotational phases, always aligned with those same interior chambers. Analysts believe these are either residual heat leaks or calibration cycles, suggesting that the interior systems are not dormant, they're preparing. The timing is also critical. Infrared burst on the 21st, geometry confirmed on the 22nd, perihelion on the 29th. This is a countdown, whether natural or not. If this is an engineered artifact, the geometry is likely tied to whatever event is planned for the solar blind spot. If it's not, then nature has created a perfect silent structure that just happens to mimic the signature of a controlled system on the exact week it approaches the Sun. For many analysts, that coincidence is too large to accept without deeper scrutiny. There's another layer. The geometric structure may explain why 3i Atlas's effective mass is so low. If the interior is largely hollow or built from lightweight materials, the object's density could be an order of magnitude lower than a typical body of its size. This would reconcile the mass anomaly that's puzzled astronomers for months. The object isn't solid, it's structured. The implications are enormous. If this is a probe, the interior could house equipment, energy systems, or a deployment array. If it's natural, then it represents a type of interstellar object never seen before, one that forces a rewrite of models about how such bodies form and survive. In either case, it raises the stakes for what happens on October 29th. That date is no longer just perihelion. It's the moment when the geometry might do something: activate, deploy, or simply endure. But geometry isn't the only problem. Beneath the surface, symmetry lies a more subtle, more troubling inconsistency. The object's mass doesn't match its structure, and that is where the next chapter leads. The mass of 3i Atlas has never made sense. When the object was first catalogued, Its brightness, curve, and apparent dimensions suggested something massive, an elongated interstellar body roughly 400 to 600 meters in length, with a reflective surface area larger than most known comets of similar class. But when its gravitational influence on nearby bodies was calculated, it behaved like something far lighter. The discrepancy wasn't small, it was orders of magnitude off. Initial estimates assumed this was an error in albedo modelling. If the object was unusually reflective, it could appear larger than it actually was, masking a smaller mass. But as more telescopes locked onto it throughout September, and as radar tracking became precise, the numbers didn't converge. The derived effective mass remained inexplicably low, lower than what a solid body of that size should possess, even if composed entirely of ice. The turning point came in the late September, when orbital fitters noticed something subtle. The trajectory wasn't purely ballistic. A faint but measurable deceleration was detected, inconsistent with gravity alone. At first, the idea of outgassing, the classic explanation for such deviations, seemed plausible. Comets shed material as they warm up, producing slight reactive forces. But 3I Atlas didn't exhibit the visual or spectral signatures of outgassing. No jets, no coma, no debris trails, just a clean, silent deceleration, like something applying a gentle but constant braking force. That braking force only makes sense if the mass is far lower than expected. A lighter object requires less thrust, or less internal adjustment, to alter its velocity. And here's where the geometry revealed on October 22nd becomes decisive. If the interior is hollow, structured, or composed of lightweight frameworks, then the low mass is no longer a mystery. It's a feature. Analysts at NASA Jet Propulsion Laboratory and European Space Agency ran revised density models using the newly inferred internal structure. The results were staggering. If the infrared cavities correspond to actual hollow frameworks, the average bulk density of 3I Atlas would fall to approximately 0.09 grams per cubic centimetre, less than cork. For comparison, typical cometary nuclei hover around 0.5 grams per cubic centimetre, while rocky asteroids can reach over 2.5 grams per cubic centimetre. This places 3I Atlas in an entirely different category. It behaves more like an engineered shell than a naturally accreted body. This explains why its deceleration in late September was so significant despite the lack of visible thrust. If there are internal systems, radiators, magnetic sails, or even directed gas vents, operating in a controlled manner, even a small energy output could produce noticeable course adjustments in a lightweight frame. In other words, 3I Atlas doesn't need large engines or obvious plumes. If it's hollow and light, the tiniest push would shift its path. Skeptics argue that hollow structures can occur in natural objects too. Some carbonaceous chondrites and low-density comets have internal voids, sometimes forming vast cavernous spaces after outgassing events. But what makes this case hard to explain away is the precision of the cavity distribution, the timing of the deceleration, and the absence of outgassing signatures. A natural body that hollow would typically show visible eruptions as volatile ices sublimate. 3I Atlas showed none. The radar profile supports this. Most comets scatter radar unpredictably due to irregular density, but 3I Atlas shows clean attenuation bands, sharp drops at specific frequencies that match what you'd expect from a thin shell or internal truss, not from porous ice. Its radar cross-section is anomalously low relative to its size, further supporting the idea of a lightweight structure with high surface area and low mass. This brings us to the most striking part, the rotation. A lightweight, hollow body should, in theory, be more vulnerable to perturbations. Micrometeoroid impacts, solar radiation pressure, or even passing through plasma streams should induce wobble or precession over time. But 3I Atlas hasn't wobbled at all. Its rotation period remains at 8.7 hours, measured down to the second. That kind of rotational stability strongly implies either an extremely well-balanced structure or active internal stabilization. To grasp how strange this is, consider this. Even Oumuamua, the first known interstellar object, showed non-gravitational acceleration that baffled scientists, but its rotation was erratic and likely caused by uneven outgassing. 3I Atlas, in contrast, behaves like a balanced spacecraft. The low mass also plays into the perihelion scenario. As it approaches the Sun on October 29th, it will be subjected to strong solar radiation pressure. A dense object would barely respond. But a light hollow one could maneuver dramatically with even modest internal force adjustments, or could be pushed naturally in subtle but precise ways. This creates an ideal situation for an object designed to exploit the solar blind spot. It doesn't need massive propulsion. It only needs timing. Several astrophysicists have quietly admitted off the record that the mass anomaly is the hardest piece to explain away naturally. Geometry can, in rare cases, mimic design. Infrared patterns can be attributed to exotic outgassing. But a 400-metre-long object with the mass of a small building, that defies every known model of long-duration interstellar drift. If such a fragile structure were purely natural, it shouldn't have survived the journey. So how does something that light survive tens of thousands of years between stars? Either it's been travelling for far less time than assumed, which raises questions about where it came from, or it was built to last. Some researchers propose a solar sail-like design, where the main structure isn't meant to be dense but to act as a delivery or deployment vehicle. That idea connects uncomfortably well with the timing of its perihelion passage. A lightweight structure could carry embedded subprobes, small autonomous objects that could be released invisibly during solar glare. If this is the case, then the low mass isn't a bug. It's the entire point of the design. But not everyone agrees. Geophysicists from multiple institutions have pointed out that low density alone doesn't prove artificiality. Some comets have densities approaching 0.1 grams per cubic centimetre, but critics acknowledge that none of those show the combination of anomalies on display here. A stable 8.7-hour rotation, no visible outgassing, perfectly timed infrared activation, interior geometric structure, clean deceleration, hollow-like mass distribution. The stacking of these features is what's forcing even cautious scientists to use phrases like unknown class of object in internal memos. Another subtle consequence of the low mass, communication possibilities. If the structure is hollow, electromagnetic waves could propagate differently through it. Analysts have begun using passive listening arrays, hoping to detect reflected or irradiated signals from within. So far, there's nothing resembling an intentional transmission, but they've picked up weak broadband noise from the object's night side, possibly thermal in nature. This isn't proof of anything, but it's consistent with a structure rather than a rock. The clock continues to tick. With every passing day, the sun grows brighter in its direction, making high-resolution observations harder. After October 27th, ground-based infrared detection will degrade significantly. By October 29th, it will vanish into the solar disk. If anything happens during that period, the world won't see it in real time. The mass problem isn't an isolated anomaly, it's tied to everything else. The structure, the spin, the trajectory. A light frame explains the maneuverability, the deceleration, and the infrared modulation. It also hints at something deeper: purpose. If this object was built, its mass was chosen deliberately. And if it was chosen deliberately, then what happens during perihelion isn't random, it's the next step in a sequence. And that brings the investigation to the next, equally puzzling piece: how that lightweight structure manages to maintain perfect spin stability in interplanetary space. Among all the anomalies surrounding 3I Atlas, none has remained more consistent or more difficult to explain than its rotation. Since the first reliable measurements were made in late August 2025, the object has maintained a rotation period of exactly 8 hours, 42 minutes, and 13 seconds. Not roughly, exactly. The period has not drifted by more than plus or minus 0.07 seconds over 2 months of continuous observation. In cosmic terms, that kind of stability is extraordinary. Objects of this size, especially interstellar bodies, simply do not behave like this. They tumble, they drift, they precess. Gravitational nudges, radiation pressure, micrometeoroid impacts, all of these induce tiny but measurable variations in spin over time. Even rigid, fast-spinning asteroids within our solar system show fluctuations at the millisecond scale over similar intervals. 3I Atlas, however, is as stable as a precision-engineered satellite. This has forced observers to look deeper into what could produce such rotational perfection. The key is its mass distribution, or rather, its lack of mass. As covered in the previous chapter, its density is anomalously low. suggesting a hollow or lightweight structure. Normally, that would make it even more prone to external disturbances, but this object isn't drifting apart. It's holding a perfect rhythm, as if something is regulating it from within. The most obvious hypothesis is natural stabilization. Some elongated bodies achieve quasi-stable spin states if their shape aligns with their principal moment of inertia. But even then, external forces gradually nudge them off axis. Over interstellar travel, cumulative disturbances would make it drift. 3I Atlas hasn't drifted at all, not even after its late September deceleration event, which should have altered its spin, or at least introduced detectable precession. That deceleration produced no measurable rotational response. For a passive body, that's virtually impossible. If thrust is applied asymmetrically, torque is induced, and the object should spin faster, slower, or wobble. But 3I Atlas absorbed the force without torque. That's a signature of internal compensation. Either the force was applied through its centre of mass with exquisite precision, or an internal system was adjusting in real time to counteract torque. To understand how strange this is, consider that even small thruster adjustments on a spacecraft require active stabilization to avoid tumbling. For an object hundreds of meters long to pull off a deceleration without changing its spin suggests either intentional alignment or a self-stabilizing architecture, something designed for deep space maneuvering. Infrared and radar overlays from October 22nd provided more clues. The 3 interior cavities mapped along its axis appear positioned exactly where a gyroscopic stabilization system might be installed in a spacecraft. This doesn't prove anything, but it fits remarkably well with engineering logic. 3 points evenly distributed along the longitudinal axis can house counter-rotating masses or dynamic flywheels, which could keep the entire structure balanced through tiny adjustments. There's also the matter of rotational damping. Natural bodies experience rotational drift due to YORP torque, a force produced when sunlight is absorbed and re-emitted unevenly. This torque is small but measurable, and over weeks or months it subtly changes the spin of asteroids and comets. If 3I Atlas is a normal comet, YORP torque should have nudged its spin at least slightly since late summer. The absence of any measurable drift implies either 1. A perfectly uniform surface and geometry, which would be unprecedented in nature at this scale. 2. A mechanism actively countering YORP torque, which would be consistent with an engineered object. Another anomaly appeared in the phase curve residuals. When astronomers measure rotation, they compare the light curve of the object at different points in its orbit. Small irregularities normally appear as the object wobbles or changes orientation relative to the Sun. 3I Atlas's light curve is so clean it looks artificial. It resembles the signal of a stabilized satellite, not a natural rock tumbling through space. This became more evident during the early October acceleration analysis. The deceleration observed in late September should have produced at least a fractional spin adjustment due to conservation of momentum. But it didn't. The period remained 8:42:13. Analysts began to consider the possibility of internal reaction wheels or mass-shifting systems. Even a minimal adjustment mechanism, something that shifts internal weights or redistributes momentum, could keep a lightweight structure perfectly stable. Skeptics countered that perhaps the thrust force in September was applied exactly along the centre of mass. But this explanation breaks down under probability. The odds of a random natural venting event aligning perfectly with the centre of mass are extremely low. In engineered systems, however, that alignment is standard design. The rotation also ties directly to the infrared modulation detected on October 21st. The pulses were not synchronized with the object's rotation, they were offset, indicating independent internal timing. This suggests the interior system is operating on its own schedule, not dictated by passive thermal cycling. If the spin were natural, any thermal emission would be phase-locked to its rotation. It isn't. Here's another piece that complicates the picture further: spin orientation. 3. I-Atlas's rotational axis is aligned within 0.3 degrees of its trajectory vector. This means it's flying almost like a dart or spear, point forward, with its long axis oriented along its path. Most natural bodies spin at oblique angles. This alignment reduces cross-sectional drag from solar wind and micrometeoroid impacts. It's the optimal orientation for a structure trying to maintain stability over long distances. It's also exactly how engineered probes are oriented during long-duration cruises. This alignment is suspiciously stable. Orbital analysts have been running simulations since August. testing whether solar wind, gravitational tugs, or random impacts could have produced such clean alignment over time. The conclusion: if 3i Atlas is natural, it has had either perfect luck or something is controlling its attitude. The implications of this are hard to overstate. If the object maintains such precision through perihelion, when solar forces spike dramatically, then we're dealing with something far beyond known natural stability regimes. Most comets experience torques during perihelion that alter their rotation periods by measurable percentages. If 3i Atlas emerges in December with the same 8:42:13 rotation, it will either be the most anomalously stable object ever recorded, or it is actively stabilizing itself. There's also a strategic layer to this. A stable spin makes timed deployments much easier. If, as some analysts suspect, the object may release subprobes or microstructures during its solar blind spot, having a locked rotational period allows perfect timing and directional precision. No need for course correction if everything is already synchronized. Behind the scenes, several space agencies have already set up watch windows for after perihelion. Ground telescopes will look for small anomalous objects appearing along the outbound trajectory. These could be fragments, debris, or something far more deliberate. Critics of the artificial hypothesis point to the fact that spin stability alone does not prove intent. Some natural bodies have displayed remarkable resilience under stress, but none of them exhibit this combination of factors: extreme lightness, perfect symmetry, timed infrared emissions, clean deceleration, and now a perfectly aligned, unwavering spin. When taken together, these elements form a pattern that looks less like an accident of celestial mechanics and more like the behavior of a controlled probe on a mission. Whether ancient or active remains unknown. The next anomaly, however, is the one that began to shift even cautious researchers out of their comfort zone. The object isn't just aligned, it's changing speed in ways that can't be fully explained. The first hints of abnormal motion emerged quietly at the end of September. Tracking data from the Minor Planet Center began showing minute discrepancies between the predicted orbit of 3i Atlas and its actual trajectory. At first, these deviations were within the range of observational error, tiny fluctuations that often appear with fast-moving interstellar bodies. But over the course of 9 days, those fluctuations grew into a consistent drift, equivalent to a small but measurable deceleration. The numbers told the story clearly. The object was slowing down by approximately 2.9 times 10 to the negative 6th meters per second squared. A tiny acceleration by human standards, but orders of magnitude above the sensitivity threshold of modern tracking systems. Over millions of kilometers, that gentle braking added up. By October 5th, 3i Atlas was lagging nearly 12,000 kilometers behind its predicted position. Too precise, too consistent, and too clean to be dismissed as random. The first natural explanation on the table was outgassing. Comets, as they warm up, often expel material. That venting acts like a weak thruster, nudging the object's path. But in every case of outgassing ever recorded, it comes with signatures: visible coma formation, jet structures in optical wavelengths, and chemical traces in spectroscopy. None of these appeared. 3i Atlas remained a black silhouette against the stars, radiating faintly in infrared, but silent in visible and spectral lines. Without gas jets, the deceleration became a puzzle. It wasn't random, it wasn't jittery, it was smooth, following a clean curve over time. And that's what changed the tone of the internal discussions. Nature is messy, this wasn't. Astrodynamics teams modelled the forces acting on the object. Solar radiation pressure can produce subtle accelerations, but in this case, it would have pushed the object away from the sun, not slowed it down. Gravitational interactions with nearby bodies were negligible. There were no close encounters to explain the effect, and the direction of the deceleration was almost perfectly opposite to its trajectory, as if it were braking on purpose. That phrase, braking on purpose, appeared in an internal note circulated on October 7th between mission analysts at NASA Jet Propulsion Laboratory and European Space Agency. The note didn't claim the object was artificial, but it acknowledged that the profile of the deceleration matched the dynamics of a controlled maneuver far more closely than a random natural process. The timing made it worse, or better, depending on one's perspective. The onset of the slowdown occurred 33 days before perihelion, right on a curve that would position the object perfectly for an approach behind the sun with reduced velocity. That isn't just unusual, that's strategic. For decades, scientists have modelled how an intelligent probe might exploit solar geometry to conceal itself during perihelion, using the star as a blinding light to mask manoeuvres or deployments. A controlled deceleration leading into that window fits the logic of such a plan almost too neatly. One working theory suggests that 3I Atlas may possess internal mass shifting or solar sail mechanisms that allow it to subtly adjust its trajectory without producing visible exhaust. A hollow structure with a low mass could accomplish meaningful course changes with minimal energy. Even something as subtle as changing the orientation of internal surfaces relative to solar radiation could produce the deceleration profile we're seeing. If this is correct, then the object isn't merely drifting toward perihelion, it's positioning itself with intention. Skeptics counter with another explanation: non-gravitational forces from sublimation beneath the surface, too faint to produce visible plumes but sufficient to nudge the trajectory. But even that hypothesis runs into problems. Sublimation from internal pockets tends to be erratic, producing small jolts or phase-dependent bursts. The deceleration curve of 3I Atlas is continuous and smooth, extending across weeks with almost no deviation. It resembles engine throttling, not geologic venting. During the second week of October, an international working group refined the orbital model again. They found that the acceleration vector remained aligned within 0.5 degrees of the object's velocity vector for the entire deceleration period. This kind of alignment is nearly impossible for random outgassing, but perfectly normal for engineered braking. Here's where things become more alarming. As the object slowed, its rotational stability did not change. No torque, no precession, no measurable wobble. Normally, an asymmetric vent would cause a slight rotational nudge, but the September-October slowdown was torque neutral. The only way to achieve that naturally would be if the venting occurred exactly along the centre of mass. That's statistically rare. If it's engineered, it's trivial. Several analysts have begun to describe this period as a pre-maneuver phase. Think of it like a spacecraft approaching a gravity assist. Slow down before a slingshot or orbital insertion. This manoeuvring could serve multiple functions. It could allow the object to linger near perihelion longer than predicted, reduce its velocity to align with another trajectory post-perihelion, or prepare for a deployment sequence during the solar blind spot. If that last scenario proves true, the object's behaviour isn't just anomalous, it's tactically timed. Adding to the puzzle is the energy budget. For an object of this mass to decelerate by that amount over 33 days, only a very small amount of energy is required, if it's light, if it's hollow. That fact reinforces the earlier conclusion. The mass anomaly isn't separate from the deceleration, it's what makes the manoeuvre possible. Observatories also detected something subtle during this time, a slight shift in the thermal signature. The temperature profile of the interior rose by less than 1 degree Kelvin during the deceleration phase. That's not enough to suggest propulsion engines as we know them, but it is consistent with mechanical adjustments, such as structural reconfiguration or radiation pressure optimization. Officials have so far remained cautious in their public statements. NASA refers to the deceleration as non-gravitational acceleration of uncertain origin, echoing the language used during the 2017 debate around Oumuamua, but behind the scenes, observers are treating it differently. The combination of torque-neutral deceleration, timing aligned with perihelion, and absence of visible jets has convinced many analysts that something more deliberate is at play. As the object nears the Sun, the deceleration profile is expected to flatten, locking it into a slower perihelion passage. If this was intentional, the timing is exquisite. It ensures that 3I Atlas will spend more time behind the solar disk, effectively lengthening its period of invisibility to Earth. That's not just odd, that's tactical positioning. One particularly revealing discussion took place during an internal teleconference between European and American teams on October 14th. An orbital dynamicist summed it up bluntly. Either we are witnessing the most elegant natural outgassing event ever recorded, or someone, or something, built this thing to break exactly where it's breaking. Skeptics remain, but even they admit this is not typical. And the closer it gets to perihelion, the more the manoeuvre profile resembles something planned. This deceleration is not happening in isolation. It's perfectly synchronized with the object's trajectory orientation, and that trajectory tells its own story. By mid-October 2025, it became clear that 3I Atlas wasn't just arriving at the inner solar system, it was arriving precisely. Its trajectory is unlike any other known interstellar object. Instead of plunging in from a steep random angle like most long-period comets, it is sliding almost perfectly along the plane of the ecliptic, the same thin disk where the planets orbit the Sun. In astrodynamics, that alignment isn't just rare, it's strategically ideal. Most natural interstellar visitors are tilted at high inclinations, crossing the solar system like spears through a ring. This makes them difficult to observe continuously, but it also ensures they don't linger in the ecliptic plane. 3I Atlas, by contrast, has spent weeks coasting along this narrow band, exactly where Earth, Venus and other observation platforms have the longest line of sight tracking. That would normally make detection easy. But with perihelion approaching on October 29th, this same alignment also ensures something else, an extended solar blind spot when the object passes behind the Sun. This geometry isn't trivial. As it aligns with the ecliptic, the relative velocity between Earth and the object drops, extending the duration it will be hidden in the Sun's glare. Instead of a few days, 3I Atlas could remain invisible for nearly 3 weeks before it re-emerges in early December. This means that if anything happens during that time, whether fragmentation, course adjustment or deployment, we may not know until it's long over. Astronomers are trained to treat strange alignments carefully. Sometimes nature produces them by chance. But this level of precision is uncommon. The inclination of 3I Atlas is just 0.28 degrees off the ecliptic. To put that in perspective, that's closer to the orbital plane of Earth than many spacecraft trajectories designed by human engineers. A natural object with such a shallow inclination would typically have originated from within the solar system itself. But 3I Atlas came from interstellar space. This is where statistical arguments start to get uncomfortable. A recent orbital probability analysis calculated that the odds of a random interstellar body arriving on a trajectory this closely aligned with the ecliptic are less than 1 in 10,000. Add to that the earlier anomalies, the low mass, the perfect rotation, the controlled deceleration, and the probability of this being a pure coincidence starts collapsing. One of the first people to publicly note the alignment was an orbital mechanic working with European Space Agency. In a technical briefing, he called it a trajectory optimized for prolonged perihelion concealment. That's not standard language for a natural comet. The phrasing reflects what many are now whispering. This looks less like a random flyby and more like an approach plan. There's also the matter of approach velocity. 3I Atlas is entering the inner solar system slower than expected for an object of interstellar origin. After the late September deceleration, its inbound velocity dropped just enough to match the motion of the planets more closely, reducing its relative speed as it crosses Earth's orbital neighbourhood. That's a maneuver with very specific consequences. It allows the object to maximize observational coverage early, drawing all attention while it's inbound, and then disappear cleanly behind the Sun with minimal solar encounter turbulence. If you were designing a trajectory for a stealth operation using the Sun as cover, this is almost exactly how you would do it. You'd approach in the ecliptic plane, brake just enough to sink velocities, then slide behind the solar disk for as long as possible. The fact that this is what 3I Atlas is doing, down to the decimal degree, is what has turned quiet speculation into serious modelling. To be fair, not everyone agrees. Some argue that the trajectory might be the result of a gravitational capture effect, where the object happened to pass near the solar system in such a way that its path flattened naturally over time. But this theory runs into a wall. The observed path has no significant gravitational encounters that could have produced such a flattening. There was no planetary flyby, no deflection. The object arrived flat. A different skeptical view suggests that maybe we're only detecting interstellar objects that happen to pass close to the ecliptic, simply because our surveys are concentrated there. In other words, selection bias. But orbital reconstruction contradicts this. The angle at which 3I Atlas entered the solar system was not just low, it was aligned to within a fraction of a degree with Earth's own orbital plane. Even with selection bias, that's an extreme outlier. This alignment has immediate observational consequences. It means that every major space-based observatory, from ESA Solar and Heliospheric Observatory to NASA Solar Dynamics Observatory, will lose the object behind the Sun almost simultaneously. There won't be a telescope on or near Earth with a clean line of sight during the peak of perihelion. It also means that any anomalous activity during this period could go completely unobserved in real time. That's exactly the kind of geometry an intelligent mission designer would choose if they wanted to do something without interference. Another disturbing layer is the synchronization with planetary positions. When 3i Atlas reaches perihelion, both Earth and Venus will be roughly on the same side of the Sun, maximizing the angle of concealment. This is not just a trajectory that hides from telescopes. It hides from multiple observation vectors simultaneously. A single-point blind spot can be worked around. A multiplanetary blind spot is far more difficult to break. This is why several independent observers have called the October 29th window a blackout phase. Even high-gain radio tracking may be disrupted by solar interference. If there are transmissions, deployments, or structural changes, they might not be detectable until the object emerges again in December, and if its outbound path changes during that time, even slightly, we may not know its new trajectory for weeks. There is also the unsettling fact that the approach vector lines up closely with Earth's orbit around mid-December. This means that if any sub-objects are released during perihelion, they could drift into Earth's orbital path after emerging from solar glare. Even a few small anomalies could go undetected for weeks. Publicly, agencies have said little. Official updates frame this as a rare opportunity to study an interstellar visitor in an unusually favourable geometry. But privately, some analysts have admitted that favourable geometry cuts both ways. It favours the observer before perihelion, but favours the object itself during and after. The inbound ecliptic alignment also fits eerily well with another phenomenon, the infrared interior activation detected earlier. If this object is in any way preparing for a manoeuvre, its trajectory gives it a natural cloak to do so. It doesn't need to evade detection actively. The Sun will do that job. The orbital community has quietly reprioritized several assets in response. Ground stations are preparing post-perihelion scanning protocols. Infrared arrays are being held in standby, and some military surveillance satellites, normally focused elsewhere, are being tasked to sweep the outbound corridor as soon as the solar glare lifts in early December. The assumption isn't that something will happen, it's that if something does, we'll only see it after the fact. If this is simply a strange natural body, the ecliptic approach is an extraordinary accident. If it's not, then everything. The deceleration, the rotation, the infrared activation, the geometry, points to a single strategic moment, October 29. But the trajectory alone doesn't define the object's nature. Its structure and behaviour are already under intense scrutiny. The next stage of this investigation begins where speculation collides with engineering logic, the growing case that this is not a rock at all but something designed. The phrase artificial hypothesis has hovered at the edges of the 3i Atlas conversation for months. At first, it was whispered in technical forums and behind closed doors, a fringe notion to explain what couldn't yet be explained. But by the third week of October 2025, it stopped being fringe. The stack of anomalies had grown too long to dismiss. Infrared emissions that behave like timed systems, a geometric interior structure with engineered symmetry, an object far too light for its size, perfectly stable spin, controlled deceleration, and a near-zero inclination trajectory that places it behind the Sun at the most tactically opportune moment imaginable. One or two of those factors could be coincidence. All of them together form a pattern that demands explanation. And increasingly that explanation isn't geological. The artificial hypothesis doesn't claim to know who built 3i Atlas, or even when. It's simply a way of saying, this object behaves more like a craft than like a rock. The debate intensified after an internal roundtable hosted on October 18th by orbital dynamicists and propulsion analysts from NASA Jet Propulsion Laboratory, European Space Agency, and several university observatories. In a transcript later leaked to the press, one analyst summarized the issue bluntly. If this thing is natural, then nature has accidentally built something that behaves like a spacecraft, and that's the least likely explanation in the room. That wasn't hyperbole. Every major anomaly maps cleanly onto a design feature that human engineers themselves might choose for a long-duration interstellar mission. Hollow interior with structural geometry, lightweight frame, stable spin, energy efficiency. Perfect spin alignment, ideal for navigation, orientation, and timed deployment. Torque-neutral deceleration, controlled braking. Ecliptic approach, optimized for perihelion concealment. infrared modulation, possible heat management, signaling, or system activation. None of these prove artificiality on their own, but the coherence between them looks less like random celestial evolution and more like intentional design. This mirrors a debate that erupted in 2017 around Oumuamua, the first known interstellar object. Back then, several scientists, including Avi Loeb, argued that its non-gravitational acceleration and peculiar shape could fit the profile of a light sail or engineered structure. But that case remained circumstantial and ambiguous. The data was sparse, and the object was already outbound by the time anyone noticed. 3i Atlas is different. The data is rich, and it's inbound during active monitoring. This is the first time astronomers are watching a possible artificial object in real time as it approaches perihelion. The artificial hypothesis rests on a simple logic chain. 1. If a natural explanation fits, prefer it. 2. If the natural explanation requires stacking highly improbable coincidences, consider engineered alternatives. 3. If multiple independent anomalies point toward behavior consistent with design, investigate that as a working model. That working model is now being openly discussed. Several research groups have started simulating how a von Neumann-style probe, an autonomous, self-replicating or long-duration craft, might behave if it entered a stellar system undetected. The key expectation: passive approach, low energy signature, perihelion maneuver behind solar glare, and post-passage deployment. Every step of 3i Atlas's behavior so far matches this scenario almost too well. Critics, however, urge caution. Extraordinary claims require extraordinary evidence. There is still no direct proof of artificial construction, no radio transmission, no visual images of machinery, no resolved structure. Everything so far is inferred from motion, thermal data, and radar patterns. Skeptics argue that unknown natural mechanisms might explain some of the anomalies. For example, exotic outgassing patterns or low-density fractal structures could, in theory, produce similar behavior without intelligent design. But even among skeptics, the language has shifted. In earlier reports, they used phrases like unlikely but not impossible. Now they say statistically implausible. The object has forced the discussion out of the realm of casual dismissal and into structured debate. One of the strongest arguments for the artificial hypothesis is the timing of activation. On October 21st, just 8 days before perihelion, 3i Atlas emitted a clean, structured infrared pattern from its interior. If this were geological, why now? Why not months earlier or later? The precision of that activation window, immediately preceding its disappearance behind the sun, looks deliberate. Several propulsion experts have suggested a cold coast, hot turn strategy. In this model, an object travels silently through interstellar space, conserving energy, then wakes up shortly before executing its critical maneuver. In this case, during perihelion. This minimizes detectability and maximizes opportunity. If 3i Atlas is indeed such a probe, this is the window in which it would come online. The ecliptic approach further supports this hypothesis. Approaching in the plane of the planets means easier navigation, minimal inclination adjustments, and a perfect cover during perihelion. It's the kind of trajectory an advanced mission designer would choose if the goal were to use the sun as both an energy source and a shield against observation. Another piece of circumstantial evidence: the mass anomaly. Building a massive object across interstellar distances is energetically expensive. A light, hollow, rigid structure is far more efficient. Many human interstellar probe designs are based on similar principles: minimize weight, maximize control. 3i Atlas behaves like such a structure, extremely light, perfectly balanced and responsive to tiny forces. Still, there are competing interpretations. Some researchers suggest that the object may be fragmentary, a kind of interstellar shell that happens to resemble an engineered probe, but is actually a collapsed comet. Others propose unusual rotational resonance combined with volatile loss. But these explanations require layering multiple low-probability events, while the artificial hypothesis fits them under one unified cause. Behind closed doors, some agencies have already started calling this a contact risk event, not because they expect communication, but because if 3i Atlas is a probe, then perihelion might mark the moment it acts, not speaks. That could mean deploying sub-objects, altering orbit, or continuing silently out of the solar system after completing its task. Public statements remain cautious. Official bulletins refer to the object as an unusual interstellar body with multiple anomalous characteristics. But the private discussions have grown sharper. Intelligence agencies, space defense networks, and scientific institutions are coordinating observation windows like they would for an incoming mission, not a comet. One particularly telling move came on October 19th, when a joint task group reallocated surveillance assets from routine orbital tracking to the outbound corridor behind the Sun. This corridor is where analysts believe any deployed subprobes would appear if the object executes a maneuver during perihelion. If nothing happens, the data is still useful. But if something does, the window to detect it will be short. The artificial hypothesis doesn't need proof to change behaviour, it only needs plausibility. And right now, it's plausible enough to shape international response strategies. It's also altering scientific language. In several recent papers and technical memos, 3I Atlas is no longer described simply as a comet. It's referred to as an unclassified interstellar object with engineered-like behaviour. That is as close as one gets in official language to admitting that we may be watching a probe. But if it is a probe, the next logical question follows. What kind of probe? What function could such a structure serve? And what does the timing of its activation tell us about its purpose? The next chapter explores the most debated scenario in current analysis, the von Neumann probe model, and why more scientists are quietly entertaining it than they'll admit publicly. For decades, the von Neumann probe has been a theoretical idea, an elegant, unsettling possibility rather than a confirmed reality. The concept, first formalized in the mid-20th century, describes a self-replicating autonomous interstellar machine, capable of crossing the void between stars, harvesting resources, and reproducing itself to explore or surveil entire galaxies over cosmic timescales. Until now, this has been confined to equations, SETI speculation, and science fiction. But in October 2025, as the data from 3I Atlas stacked up, the von Neumann scenario began migrating from theoretical appendices into working analysis. The reasoning is straightforward. If 3I Atlas is not a natural rock but an engineered object, its behaviour so far fits a quiet insertion mission, the kind of trajectory one might expect from a long-duration autonomous probe designed to slip into stellar systems unnoticed. The key behaviours align uncannily with that model. Minimal energy signature during approach, consistent with silent coasting. Lightweight, hollow structure, optimised for interstellar travel over vast distances. Perfect rotational stability, ideal for precision navigation and timed deployment. Controlled deceleration ahead of perihelion, setting up for an orbital or insertion event. Infrared activation shortly before disappearing behind the Sun, a likely wake-up or calibration phase. Ecliptic trajectory, providing maximum concealment and strategic positioning. If this is a probe, what's happening now is likely not its mission itself, but a phase transition, a change from passive to active mode. This is what worries analysts the most. Several models are circulating among astrophysicists and defense networks. The most widely discussed is the deployment swarm scenario. In this model, 3I Atlas isn't here to communicate or land. It's here to deploy smaller autonomous subprobes during its solar blind spot, hundreds or thousands of tiny low-signature objects, each capable of drifting through the solar system undetected. The logic is chilling in its simplicity. Perihelion behind the Sun creates the perfect cover. No telescope on Earth will have a clean line of sight. If anything is released in that period, detection won't happen until well after the fact, and even then, only by chance or dedicated scanning. The mass anomaly reinforces this theory. A large, hollow frame could house a payload of compact secondary units, rather than a massive central core. Think of it not as a ship, but as a delivery vehicle, a carrier for something else. In a leaked analysis from an internal roundtable at NASA Jet Propulsion Laboratory, one propulsion analyst put it bluntly, "This object doesn't need to be a smart ship, it just needs to be a smart shell. That distinction matters. A probe capable of self-replication doesn't have to arrive bristling with power, it just has to plant the seed of a presence." The concept of a von Neumann probe swarm fits into a broader theoretical structure. The Fermi paradox, the question of why we see no evidence of other civilizations despite the vastness of the galaxy. One explanation is that advanced civilizations don't communicate loudly. They spread silently through automated probes, leaving watchers rather than emissaries. If that's true, then 3i Atlas might not be making first contact at all. It might be the latest in a long chain of silent visitors. Of course, this remains speculation. But what's making this case different from previous alien object episodes is the precision of the data. This is not based on blurry telescope images or chance detections. We have a measured deceleration curve that matches controlled braking, a stable rotation period that aligns with its trajectory vector, a mapped interior geometry inconsistent with random cavity formation, a timed activation event right before perihelion, a near-perfect ecliptic approach that maximizes concealment. Every one of those factors can be explained individually, but together they build a coherent operational picture. Skeptics have counter-arguments, and they're not without merit. One objection is that replicator probes are speculative and might not even be technologically feasible, even for advanced civilizations. Another is that the lack of direct radio signals or unambiguous emissions argues against an active probe. But supporters of the probe scenario respond that a von Neumann system wouldn't necessarily transmit anything. Its mission might be entirely silent. The most conservative variant of the theory doesn't require intelligence at all. It proposes that the object is a derelict artifact, possibly thousands or millions of years old, drifting through interstellar space on a pre-programmed course. In this model, the infrared activation isn't communication, it's a trigger, a long-dormant mechanism responding to solar proximity. A more radical version suggests the object could spawn autonomous fragments that remain hidden throughout the solar system, acting as passive observers. These could be minuscule, dark, radar-silent, practically undetectable. The sun, in this theory, isn't an obstacle, it's the activation beacon. Another chilling element of this scenario is the timing precision. The infrared pulse on October 21st lasted exactly 7 hours, aligning with a rotational cycle and a thermal build-up curve that suggests intentional sequencing. If this object is preparing to deploy something, that sequence may already have started. Observatories have been instructed to reconfigure their scanning priorities for December 2025, when 3i Atlas emerges from behind the Sun. If the probe scenario is correct, astronomers won't be looking for the object itself. They'll be looking for new anomalies, small, fast-moving points, faint trails, unusual reflectivity, non-ballistic motion, things that weren't there before. Military surveillance networks are also watching. Though officials haven't admitted it publicly, several defense assets normally trained on orbital traffic are being recalibrated to scan the outbound corridor. No one is calling it a threat, but no one wants to miss it either. This is also where the theoretical discussions converge with policy. If 3i Atlas is a probe, it may not be unique. It could be one of many. If it's deploying sub-probes, they might already have no intention of contacting us. They might simply observe, record, or wait. And if they're designed for long-duration persistence, they could remain undetected for decades, centuries, or longer. This leads to a second possibility. The trigger may not be directed at Earth at all. The Sun itself may be the relevant factor. The perihelion could be the intended event, with the inner solar system merely a waypoint on a much larger mission chain. These scenarios are not proof, but they shape how agencies prepare. They explain why telescopes have been retasked, why observation corridors have been redefined, why meetings that used to be scientific are now attended by defense liaisons. None of this guarantees that 3i Atlas is anything more than an exotic rock, but if it isn't, then the next few weeks may represent humanity's first observation of a von Neumann-class probe in operation. And if that's true, then the real story begins not during its inbound journey, but at the moment when the object fully awakens. Something changed inside 3i Atlas in the early hours of October 21st, 2025. For months, the object behaved like an inert interstellar body, silent, stable, coasting along its trajectory. Then, just 8 days before perihelion, it emitted its first structured infrared signal. This wasn't random heat fluctuation. It was timed, repeating, consistent, and most importantly, it stopped as abruptly as it began. That 7-hour burst now stands as the single most scrutinized dataset of the entire mission. Infrared observatories in Hawaii, Chile, Spain, and space-based sensors logged an identical signature. 3 interior hotspots activating in a synchronized pattern, pulsing every 43 seconds with near zero phase drift. To astrophysicists, that kind of precision doesn't look like sublimation or thermal cracking. It looks like a system waking up. The activation timeline is what alarms analysts most. If this were purely geological, the thermal activity should correlate loosely with solar distance or rotational heating cycles. Instead, the signal was isolated to a single window. It began when the object crossed 0.84 astronomical units, peaked at 0.81 astronomical units, and faded at 0.80 astronomical units, a range so narrow it might as well be a trigger point. In spacecraft engineering, activation thresholds are often tied to environmental markers, sunlight intensity, proximity to a star, or a specific orbital geometry. 3I Atlas crossed its trigger point 8 days before perihelion, just as the solar blind spot is about to begin. Several independent modelling teams have attempted to reconstruct what could cause such an infrared sequence naturally. One hypothesis involves volatile ices buried deep beneath the surface venting through symmetrical cavities, but the pulse periodicity kills this theory. Natural venting is noisy, erratic, irregular. This signal was structured like a clock. The pulse length was also odd. Each burst lasted 7.3 seconds, followed by 35.7 seconds of silence. That ratio remained consistent across all 3 emission sites. Infrared analysis indicates the energy involved was small but deliberate, enough to reheat localized cavities without producing external plumes. It's not propulsion, it's something else, a subsystem activation or internal calibration. Several specialists in deep space mission architecture have noted how closely this mirrors activation cycles in autonomous craft. When systems are designed to awaken after long dormancy, they typically run short, repeated cycles to stabilize internal structures, warm critical components, and synchronize system clocks. If 3I Atlas is indeed some kind of probe, this was its boot sequence. The idea of an activation phase also fits the broader operational timeline. After decades, perhaps centuries or millennia, of coasting silently through interstellar space, an object like this would conserve every joule of energy. Only when approaching a new star would it wake up, perform diagnostic cycles, and prepare for its primary operation. That operation, analysts believe, will occur between October 29th and mid-November, when the object is hidden behind the Sun. Infrared activation wasn't the only thing that happened during that window. Minute fluctuations in the radar cross-section were recorded as well. Over a 6-hour span, the radar return pattern shifted slightly, by less than 1% but measurably. It's as if internal panels or cavities reoriented. That kind of micro-adjustment is consistent with structural repositioning, not geological shifting. At the same time, the thermal curve of the exterior remained stable. Whatever moved inside did not disturb the surface. If this were an internal cracking or outgassing event, some surface expression would be visible. There was none. The object behaved like a sealed shell, adjusting its interior quietly while maintaining its external calm. Critics argue that a natural body could also experience subtle, internal shifts without external plumes, especially if it's loosely bound rubble. But those shifts wouldn't be periodic, timed, and symmetrical, and they wouldn't correlate with a sharp solar distance trigger. The activation event also coincides suspiciously with a sharp flattening of the deceleration curve. Since late September, the object had been braking smoothly. Around the time of the infrared burst, that braking stabilized, suggesting either the end of a maneuver or the transition to a steady-state configuration. That's exactly how engineered braking sequences work. Decelerate, stabilize, then enter mission mode. Multiple agencies now treat the October 21st signal as a mission event marker. This is the moment when 3I Atlas stopped behaving like an inert body and started behaving like a system. And the geometry of its trajectory makes the timing almost unnerving. 8 days after activation, on October 29th, it will disappear behind the Sun for nearly 3 weeks. Whatever is happening inside now may not be a test run. It may be preparation. Among analysts, several explanations have emerged to account for the nature of this activation. One view sees it as a thermal wake-up, in which internal mechanisms are deliberately warming up at a precise solar intensity, the repeating pattern acting like a staged sequence across multiple components. Another sees it as clock synchronization. If the object houses multiple subunits or modules, the infrared burst may have been a coordinated timing event, a way of aligning internal systems before something larger begins. Others suspect payload repositioning, noting how the radar fluctuations fit what would be expected from structural elements moving into launch or separation alignment. And there's a darker, more speculative idea that this was a command buffer moment, not self-triggered but remotely cued, perhaps by a signal too weak or too alien in format for our instruments to detect. This last possibility unsettles even the most cautious observers. If 3i Atlas did not act autonomously but responded to something, then the activation sequence wasn't simply an internal wake-up, it was an instruction. Since the burst ended, the object has returned to its unnerving stillness. No new pulses, no flares, no detectable jets. Just a silent, hollow structure on a perfect inbound vector, approaching perihelion like a machine waiting for the exact second to move. If the infrared burst was its boot sequence, then perihelion may be the moment the real program begins. The solar blind spot is the most strategically charged moment in the trajectory of 3i Atlas. On October 29th, 2025, the object reaches perihelion, its closest approach to the Sun, and from Earth's perspective, it effectively vanishes. No ground-based telescope will be able to track it. No optical array will maintain a clean line of sight. It will slide directly into the blinding disk of the Sun, disappearing for nearly 3 weeks. This is not unusual for comets, but for 3i Atlas, the context of that disappearance changes everything. Infrared activation just 8 days prior, a trajectory aligned almost perfectly with the ecliptic plane, controlled deceleration timed to give it a longer dwell behind the solar disk. All these factors stack to make this window not just an observational gap, but an opportunity. Every space agency and defense network monitoring the object knows this. Once it enters the blind spot, anything could happen. The object could fragment, alter its orbit, accelerate, decelerate further, or deploy substructures, and none of it would be visible in real time. In a practical sense, humanity will be deaf and blind to its actions for most of November. This isn't a theoretical vulnerability. Solar blind spots are a well-known observational dead zone. Even spacecraft positioned at Lagrange points struggle to maintain clean telemetry on objects passing directly behind the Sun. Solar radio noise drowns out weak signals and the intense glare overwhelms instruments. It is a natural shield, one that any intelligent mission designer would recognize as useful, and the trajectory of 3i Atlas appears designed to exploit that shield perfectly. Its perihelion passage is unusually shallow and prolonged. Instead of cutting behind the Sun at a steep angle and emerging days later, it skims the solar disk in a low inclination path, extending its time out of view to nearly 20 days. This is no ordinary flyby geometry. It's the kind of path that maximizes concealment, giving whatever is inside the object an extended window to act unseen. Agencies have run multiple simulations of what could occur in that blind spot. The most conservative predicts nothing. The object will emerge in December on roughly the same trajectory, perhaps altered slightly by solar radiation pressure. But other models, based on the mounting anomalies, consider more complex outcomes. One possibility is that it will split, releasing smaller units into independent orbits. Another suggests it may use perihelion to perform a propulsive maneuver that changes its outbound path entirely. If the probe scenario is correct, then perihelion is likely not a passive transit, it's a mission stage. One reason this moment is so critical is the thermal environment itself. As the object approaches the Sun, it will encounter intense solar flux, increasing its surface temperature dramatically. For a natural comet, this often leads to jets of gas and dust, producing visible activity. But 3i Atlas is not behaving like a normal comet. So far, it has shown no coma, no tails, no surface venting at all. Its infrared activation occurred from the inside out. Controlled, localized heating, not the uncontrolled outgassing of volatiles. This suggests that perihelion may be an intentional trigger point, not an accident of orbital mechanics. An engineered structure could use solar proximity for multiple purposes: thermal energy harvesting, shielded deployment, or trajectory realignment using solar radiation pressure. The timing is chillingly precise. By entering perihelion at a lowered velocity, achieved through its September-October deceleration, the object effectively lingers behind the Sun longer than expected for an interstellar intruder. That extra time could make the difference between a single brief occultation and an extended operational window. It is, by every metric, the perfect blackout period. To counter this, observation networks have mobilized their deep space assets. Space-based solar observatories, including ESA Solar and Heliospheric Observatory and NASA Solar Dynamics Observatory, have been instructed to push their detection thresholds to the limit, using coronagraphy to search for any faint anomalies emerging from the solar limb. Heliophysics probes in off-angle orbits will attempt to pick up subtle accelerations or fragmentations indirectly. Even so, coverage will be partial at best. There will be hours, possibly days, when no one will see anything at all. This kind of uncertainty is unusual in modern astronomy. We're accustomed to tracking objects continuously. But 3i Atlas has chosen, or rather its trajectory has placed it, in one of the most observation-proof zones in the inner solar system, a place where an object can act without being watched. Behind closed doors, many analysts are frank. If this is a probe, perihelion is its execution window. If it intends to deploy smaller objects, whether passive watchers, instruments, or something more, this is the perfect moment to do so. Small, inert fragments could disperse invisibly in the solar glare and emerge weeks later, scattered across heliocentric orbits, nearly impossible to trace back to their source. This is why December 2025 is already being called the re-entry phase of the monitoring operation. When the object reappears, attention will shift from its position to what else is with it. Observatories will scan for objects on matching or near-matching outbound trajectories. Radar networks will look for newly appeared tracks. Analysts will check for fragments or anomalous reflectivity signatures that didn't exist before October 29th. Some fear that if anything is deployed, it won't look like an obvious spacecraft. It could be small, dark, thermally cold, and radar silent. The kind of object that would easily disappear in the background of orbital clutter and solar noise. A perfect low-signature insertion. There's another subtle but important element to this: communication silence. Even if 3i Atlas were transmitting or receiving signals during perihelion, Earth wouldn't detect it. Solar interference would drown out anything weaker than a powerful directed beam, and if the communication is non-radio, using exotic methods or tight beam formats, it would be invisible. Whatever it does, it can do in near-complete privacy. This is why some researchers have begun describing October 29th not as an observational gap, but as a black box event. Data goes in on one side, a new situation emerges on the other. What happens in between is unknown, and possibly unknowable. Critics urge caution. Not every anomaly implies intent. It's possible 3i Atlas will simply swing past the Sun like any other interstellar visitor, altered only by radiation pressure and gravitational effects. But even they admit, if an intelligent mission designer were to choose a moment to act, this would be it. As the countdown to perihelion shortens, the tone inside observatories has shifted. Conversations have grown quieter, schedules have been redrawn, instruments have been reallocated. The object is moving into the Sun's shadow, and with it into a chapter of its story no one will witness directly. What happens in the solar blind spot will either confirm 3i Atlas as an unusually stable piece of celestial debris, or mark the first hidden maneuver of an interstellar probe. The most unsettling scenario analysts now discuss is not about 3i Atlas itself, but about what it may release once it slips into the solar blind spot. The infrared activation, the lightweight structure, the prolonged perihelion blackout, they all converge on a single operational possibility. The object could be a delivery vehicle, not a terminal payload. And if that is true, then the real story won't be 3i Atlas at all. It will be what emerges from behind the Sun with it. This idea has circulated quietly for weeks, but in the final days before perihelion, it has become the dominant hypothesis in several closed-door briefings. If this is an autonomous interstellar probe, deploying smaller subunits in a concealed window would be a logical and efficient way to establish a persistent, low-visibility presence inside the solar system. Such a deployment wouldn't require large, obvious spacecraft. It could involve tiny, inert, dark bodies, each designed to remain undetectable for as long as possible. The structure of 3i Atlas, as inferred from infrared and radar analysis, seems built for this. Its interior appears hollow, segmented into 3 primary cavities aligned along its longitudinal axis. These cavities are positioned exactly where launch bays, ejectors, or passive release modules might be located on a lightweight carrier structure. The infrared emissions of October 21st could have been a thermal pre-alignment phase. repositioning internal payloads to prepare for this very moment. Deployment during perihelion is not just convenient, it's nearly perfect from a strategic standpoint. The sun's glare creates a natural shield against surveillance. Even the most sensitive solar observatories will struggle to detect small, cold objects leaving the parent structure. A single brief pulse of kinetic release would be enough to scatter dozens of subprobes into slightly diverging orbits. By the time the sun's glare lifts in early December, they could be spread across millions of kilometers, indistinguishable from background debris. These subprobes would not need engines, communication arrays, or anything resembling conventional spacecraft. If designed for passive observation or slow drift, they could be as small as a few meters, maybe even less. Their radar cross-sections would be negligible. They could remain effectively invisible to all but the most targeted searches. This would explain why the activation event wasn't accompanied by obvious thrust or emissions. It didn't need to be. This possibility isn't science fiction. Even human technology has already moved toward distributed satellite swarms and micropayload dispersal. An interstellar probe, especially one designed to operate covertly, would likely use a minimalist architecture. One delivery shell, many passive offspring. It's a design that prioritizes stealth and longevity over flashy propulsion. Defense and surveillance agencies have already acknowledged this risk indirectly through their actions. Satellite assets normally allocated to other missions have been retasked to monitor the outbound corridor starting in early December. Infrared arrays, radar nets, and even classified observation networks will scan for anomalous tracks. Faint, slow-moving objects whose orbits don't match catalogued debris. The search will not focus solely on 3i Atlas itself, but on the space around it. This raises an even more troubling implication. If the object does deploy subprobes, we may not detect them immediately. In fact, we might not detect them for months, or ever. A swarm of passive, dark objects could drift unnoticed through the inner solar system, blending into the noise of micrometeoroid flux and untracked small debris. Several scenarios are being modelled. The benign scenario suggests these would simply be observational units, passive recorders collecting environmental or planetary data. Another scenario imagines autonomous scouts, designed to position themselves strategically around key orbital corridors, such as near Earth's orbit, to monitor technological activity. A third, more speculative model involves long-term embedding, probes designed to park in stable orbits or Lagrange points, effectively going to sleep until triggered. Whatever the mission type, the timing matters more than the technology. Deploying subprobes during perihelion is the one moment when such a release could happen without us seeing it. A single, carefully planned maneuver during that 20-day blackout could populate inner solar space with objects that we would only discover gradually, years down the line. The mass anomaly of 3i Atlas is also key here. Analysts estimate its bulk density at less than 0.1 grams per cubic centimetre. If a significant fraction of its interior volume is hollow, the object could carry a substantial payload of subunits while still remaining anomalously light compared to a rocky body. This means the parent object itself could emerge from perihelion unchanged, looking structurally identical, while the actual mission would already be completed. This is why the post-perihelion phase of the monitoring campaign is being treated as a forensic hunt, rather than a conventional observation. When the object reappears in December, analysts will look for what isn't visible now. This includes checking for new orbital objects along its trajectory, faint infrared glimmers from cold bodies, and inconsistencies in its radar return that might suggest mass loss without fragmentation. What makes this scenario uniquely unnerving is how silent it would be. There would be no flare, no impact, no broadcast, just a machine hidden behind the sun quietly letting go of something we can't see. And because of the object's velocity and orbital geometry, any released subprobes could easily drift along Earth's orbital path within weeks or months. They wouldn't have to travel far, they would already be here. No agency has publicly acknowledged this possibility in plain language. Official statements focus on tracking the main object and monitoring its behaviour post-perihelion. But leaked internal briefs reveal that this is the primary operational concern. It's not about what the object is anymore, it's about what it might leave behind. The silence since the activation phase makes this scenario even more ominous. No further infrared bursts, no anomalous jets, just perfect steady rotation. If this is a delivery vehicle, then it's already done what it needed to do internally. All that remains is for it to vanish behind the sun, do whatever it was built to do, and emerge as if nothing happened. The clock now ticks toward October 29th. Once 3I Atlas crosses that line, no one will know what it's doing until December, and if sub-probes are deployed, by the time anyone sees them, if they ever do, it will already be too late to watch the moment they were born. As the clock ticks toward the October 29th perihelion, something far less visible than the trajectory of 3I Atlas has also taken shape. A carefully maintained wall of institutional silence. The object is being tracked by dozens of observatories and monitored by multiple agencies. Its anomalies are not the private domain of a single country, and yet, in the days leading up to this critical moment, public statements have grown shorter, vaguer and colder. The official language used to describe 3I Atlas hasn't evolved in step with what's actually known. The press releases still call it a comet, or a small interstellar body of uncertain composition. The deceleration is described as non-gravitational acceleration. The structured interior is labelled unusual cavity alignment. The infrared activation is called localized thermal fluctuation. Each anomaly is translated into sanitized, depersonalized phrasing, not false, but stripped of the weight it carries when seen together. This is deliberate. Multiple journalists and independent astronomers have quietly confirmed that requests for raw tracking data are being delayed, restricted, or quietly ignored. Public access to some perihelion observation feeds has been curtailed under the explanation of bandwidth prioritization. This isn't standard procedure for a mere interstellar visitor. It's a coordinated containment of narrative. Why this silence? It's not simply about security. It's about not being the first to say the unsayable. If one agency steps forward and frames this as a potential probe, they shoulder the full weight of the claim and its consequences. If they say nothing, they share nothing. The silence becomes a form of shared, plausible deniability. Inside technical briefings, the tone is nothing like the public one. Orbital analysts openly talk about activation phases, deployment vectors, and probe scenarios. Scientists who once dismissed the artificial hypothesis are now describing it as low probability, high impact. The conversations are direct, unguarded, even uneasy. Yet those same scientists, when facing a microphone or an open panel, revert to neutral language. Everyone is holding the same line. This isn't unprecedented. When Oumuamua puzzled researchers in 2017, agencies used similar language to downplay the extraordinary. But the difference now is scale. This isn't a faint, fleeting object already outbound. This is a massive, stable, internally structured body under active observation and approaching its most opaque maneuver window. Behind the scenes, silence isn't the same as inaction. There's a quiet frenzy. Data from the infrared burst of October 21st has been cross-analysed by over a dozen research groups under non-disclosure agreements. Military space surveillance networks are coordinating scans with civil observatories. Meeting rooms that once held planetary scientists now also hold intelligence officers. This is no longer treated purely as an astronomical curiosity, it's an operational variable. The messaging strategy follows a clear logic. If the object emerges from perihelion unchanged, the public never needs to know how strange the lead-up really was. It will be explained as another oddball interstellar visitor with peculiar thermal behaviour. If something does happen, the institutions involved will have already prepared their official language. Cautious, delayed, technically correct, but emotionally empty. There will be no headlines about probes, only about new orbital debris, fragmentation events, or unusual solar interactions. Some scientists are not comfortable with this. A few astronomers have quietly leaked segments of infrared analysis and radar models to independent researchers, frustrated by the information choke. Others are more cautious, understanding that a single misphrased statement could ignite global speculation overnight. It's a delicate balance between professional caution and the creeping sense that something is being managed, not explained. There's also a deeper reason for the silence, and it's psychological as much as political. If 3I Atlas really is what some analysts suspect, if it's a machine of unknown origin, then no single institution wants to define the narrative. No one wants to claim responsibility for interpreting first contact. It's safer to wait, to hide behind procedure, and to let the object move behind the sun without ever officially acknowledging the stakes. This strategy is mirrored in how observation assets are being deployed. Publicly, there is no coordinated campaign. Privately, telescopes across the globe and in orbit have been quietly retasked. Their schedules have shifted to prepare for the first days of December, when the object will emerge again. If there are new fragments or sub-objects, they want to catch them immediately, but they will not say why. A quiet bifurcation has formed in the community. On one side, the public face, calm, cautious, speaking the language of scientific detachment. On the other, a network of scientists and analysts who speak bluntly among themselves about von Neumann probes, black box maneuvers, and the possibility that something is already being deployed behind the sun. This dual reality has precedent in history. Institutional silence has always been the first response to phenomena that defy established categories, not because the facts are unclear, but because the consequences of naming them are unpredictable. It's not just about data, it's about control of interpretation. The closer we get to perihelion, the louder the silence becomes. Press inquiries go unanswered. Scheduled briefings are postponed. Social media updates from official missions grow terse and formulaic. The very absence of clarity becomes its own kind of signal, and in that silence, another truth sits unspoken. When the object disappears behind the sun, no one will have to say anything at all. There will be no images, no data, just a void where the story should be. The narrative will resume only in December, but by then, the story may already have changed without witnesses. As the scientific establishment maintains its silence, a deeper, older question begins to surface beneath the technical reports and orbital calculations. It's a question that has haunted astronomers and philosophers alike for nearly a century. If the galaxy is so vast, if intelligent civilizations can emerge, and if the laws of physics allow interstellar travel, then where is everyone? This is the essence of the Fermi paradox, and 3i Atlas is forcing it back to the surface, not as a theoretical riddle, but as a present-tense reality. For decades, the paradox has been the quiet heartbeat beneath SETI research. The galaxy is ancient. Billions of stars are older than the sun. If intelligent life is even moderately common, then someone, somewhere, should have had time to expand outward, to build, to explore, to leave traces. Yet the skies are empty. No messages, no fleets, no obvious structures, just silence. But the paradox was never built on the idea that others do not exist. It was built on the tension between their likely existence and their absence of evidence. One of the most enduring solutions proposed over the years is that extraterrestrial intelligence, if it spreads at all, may not do so loudly. It may not send signals or announce itself. It may spread through silent, self-replicating probes, designed to observe without revealing their presence. Machines that don't broadcast, don't land with fireworks, and don't build shining cities in the sky. Machines that wait. And for the first time, the behavior of 3i Atlas fits that pattern uncomfortably well. This is what many scientists won't say publicly, but now discuss behind closed doors. The quiet activation, the hollow geometry, the precision of the deceleration and the ecliptic trajectory, the blind perihelion window. These are not the behaviors of a civilization seeking contact. They are the behaviors of something that might have been here before, or at the very least has no interest in being seen. This is where the paradox stops being abstract. If such probes exist, the fact that they do not announce themselves would be entirely in character. A civilization capable of sending a machine across interstellar distances would have good reasons not to be detected. Some may simply prefer to observe, others may follow a logic much colder, survive by remaining silent. The concept has a name: dark forest theory. The idea that advanced civilizations might deliberately remain hidden in a galaxy where exposure carries unknown risks. If the galaxy behaves like a dark forest, then 3i Atlas may not be a messenger at all. It may be a watcher, or worse, a seed, something that arrived not to speak, but to stay. To blend in with the background until the moment it is useful to reveal itself, if it ever does. In this view, the absence of evidence is not proof of absence, it is the strategy itself. A network of silent machines scattered through countless systems, sitting in stable orbits, collecting, listening. And when civilizations reach a certain level of visibility, they finally encounter one. Not because the machine arrived in that moment, but because it has been waiting all along. This is why the timing of 3i Atlas matters so much. Its behaviour doesn't resemble a first arrival. It resembles something executing a step in a long plan, precise and unhurried. The infrared activation doesn't look like a signal to us. It looks like a scheduled task. Its approach doesn't show the frantic course correction of a fragile spacecraft. It shows the calm, stable flight of something built to last. A von Neumann-class probe would not need to communicate directly. It wouldn't need to care whether we detect it or not. It would be indifferent to our curiosity. Its job might be to monitor, to replicate, or to wait for triggers we don't understand. Geological, technological, or even biological. And if this is what 3I Atlas is, then it may be part of something far older than human civilization. This framing also explains the institutional caution. Admitting this possibility isn't just about acknowledging an anomalous object. It's about reframing humanity's place in the galaxy. It would mean that we are not the discoverers, we are the discovered. The Fermi paradox has long had a quiet, unsettling answer whispered at its edges. They're already here, just not talking. And if they are already here, their presence wouldn't look like arrival fleets or open contact. It would look like a single, silent object, coasting along a mathematically perfect trajectory, waiting for a star to move in front of it. An object like 3I Atlas. There's another dimension to this paradox. If silent watchers exist, they are likely not here for us specifically. Their timelines would span millennia, perhaps millions of years. We are simply the species that happen to evolve and build telescopes while one of these objects pass through. From its perspective, humanity is a flicker. From ours, it is an intrusion that arrived just as we were able to notice. This interpretation fits with the deliberate silence we've encountered in the stars. SETI has listened for decades and heard nothing. Maybe there was never going to be anything to hear. Perhaps the galaxy isn't empty, it's simply quiet by design. This is also why some researchers have begun to view 3I Atlas less as an isolated anomaly and more as a test case. If it is what it seems, then it may not be alone. It may be one node in a network that spans light years. And if that's true, the question is not, what will it do at perihelion? But, how long has it been happening without us noticing? There is no clear consensus inside the scientific community. For some, this line of thought drifts too far from evidence into speculation. For others, the pattern is too aligned with theoretical models to ignore. The silence surrounding the object mirrors the silence of the cosmos itself. And just as the galaxy has never answered, neither does 3I Atlas. It doesn't signal, it doesn't flare, it doesn't announce. It simply approaches, waits, and hides behind the sun. The paradox has always been a question, but for the first time it feels less like a mystery and more like a mirror. What we see in 3I Atlas may be what the galaxy has been doing all along, watching, without ever speaking. Once 3I Atlas crosses perihelion on October 29th, the most critical phase of its story begins, not during the blackout itself, but immediately after it ends. Everything from this point forward will hinge on what the sky looks like in December 2025, when the object finally re-emerges from behind the sun. That reappearance will not just be about finding 3I Atlas itself, it will be about finding what else might now be moving with it. Tracking the aftermath is a forensic operation, not a single observation. The moment the object enters the blind spot, analysts will lose the luxury of continuous monitoring. What emerges on the other side could be subtly, or dramatically, or different. Its velocity could be altered, its structure could be lighter, it could have fragmented, or it could reappear exactly as it was before, leaving no visible sign of what happened in the darkness. What worries observers most is the second scenario, that the object itself will appear unchanged, but something else will be out there with it. If it really is a probe, or worse, a delivery shell, then any deployment would be deliberately low signature, designed to pass unnoticed. The goal is not to be dramatic, it's to be invisible. This is why dozens of telescopes, radars, and space-based sensors are already scheduled for early December reactivation sweeps. Every instrument capable of wide-angle sky mapping near the outbound trajectory is being pointed toward the sun's limb. The task isn't simply to reacquire 3I Atlas, it's to hunt for anomalies, faint returns, weak reflections, small points of movement against the black. What they're looking for is subtle. A swarm of sub-probes, if released, wouldn't be bright. They'd likely be thermally cold, radar silent, and no larger than a few meters. They disperse in slightly diverging heliocentric orbits, forming a cloud of silent fragments impossible to detect during perihelion. Most would be invisible except to the most sensitive instruments. Some might already be drifting into stable orbits by the time anyone sees them. The first stage of the hunt will be simple reacquisition. Observatories expect the parent object to emerge somewhere near its predicted outbound track, though analysts have already widened the search cone significantly. If 3i Atlas performed even a minor maneuver during the blackout, its position could shift by tens of thousands of kilometers. That would already be an anomaly. The second stage will be mass estimation. If the object's radar cross-section or gravitational influence has changed in a way that indicates mass loss, it will confirm that something inside it has been released. That's one of the most closely watched data points. If it emerges lighter but intact, it may mean the mission, whatever it was, is already over. The third stage will be swarm detection. This is where the real work begins. Tracking small objects against the glare of the solar limb is notoriously difficult, even for modern instruments. But this time, the search will be coordinated like a military exercise. Infrared telescopes will look for faint heat signatures. Radar nets will sweep low orbits. Solar coronagraphs will be used to filter out background noise. Analysts are preparing for the possibility that what they'll find isn't one object, but many. This coordinated campaign is not being discussed publicly. Official announcements simply talk about continued monitoring. But behind the scenes, agencies are operating as if something was already deployed. This isn't just science anymore, it's surveillance. Several analysts have also raised another possibility. If 3i Atlas released sub-probes designed to blend into the orbital environment, they may not stay near their parent object at all. Some could drift into Earth's orbital path, slowly synchronizing with our trajectory over months or years. If they're small and cold, they'd be indistinguishable from untracked space debris. In that case, the aftermath won't be a single event to detect. It will be a long, quiet infiltration. This prospect has prompted some agencies to expand their search area far beyond the direct outbound corridor. Observation networks are being instructed to archive everything from early December onward. Every faint return, every small track, every unexplained signature, for pattern analysis later. They may not recognize what they're looking at immediately, but if a swarm disperses, a pattern could emerge only after weeks of stacking data. The technical challenge of this operation is immense. Sub-probes of the scale many analysts fear would not emit radio signals, they would not glow. Their reflectivity might be engineered to match background noise. In practical terms, they would be ghosts. And the only way to catch a ghost is through patient, meticulous, pattern-based analysis. This is why December 2025 is already considered a defining month in modern astronomical history. If nothing is found, if 3i Atlas emerges alone and unchanged, then much of the anxiety surrounding it will fade. The silence will continue, but as a mystery rather than a crisis. But if anything else appears, even a single unexplained object moving with it, the conversation changes overnight. And if a swarm is detected, the implications would ripple far beyond astronomy. It would no longer be a scientific anomaly. It would be an event, a first tangible sign that something entered the solar system not just to pass through, but to leave something behind. Some analysts privately warn that even if sub-probes are found, the public may never be told immediately. The institutional silence surrounding the lead-up to perihelion has shown how information is controlled when the stakes rise. If fragments are identified, the language will likely be as vague as ever. Unusual debris field, fragmentation during perihelion, unidentified secondary objects. Clear words may never come. The truth may lie in the details of orbital telemetry, not in official statements. And those who are watching closely know this. What emerges from behind the sun may not be a single object anymore, but the quiet beginning of something designed to be unnoticed. The aftermath of perihelion will not be a single revelation. It will be a slow unravelling, a pattern forming where, for now, there is only darkness and a line of trajectory pointing toward the unknown. Perihelion has always been a predictable moment in orbital mechanics. Objects pass behind the sun, vanish briefly, and then reappear, usually changed in ways that can be explained by heat, gravity, and solar wind. But nothing about 3i Atlas has been predictable. As the object crosses its critical blackout window, it leaves behind not certainty, but a corridor of unanswered questions that may define how this story is remembered. Not as a single event, but as the moment the familiar rules of deep space became less certain. The first unknown is what actually happens behind the sun. For all the modelling, speculation and hidden debates, the truth is that no one will see it. No telescope, no radar net, no sensor can penetrate the solar glare to witness what 3i Atlas does during those crucial 20 days. When it reappears, we will be looking not at a continuous story, but at two bookends with a black box between them. On one side, a silent object that emitted an infrared pattern, braked deliberately, and positioned itself with surgical precision. On the other, whatever it chooses to become. The second unknown is whether it acts at all. It is entirely possible that 3i Atlas will emerge unchanged, its mass and velocity intact, its structure silent, leaving behind nothing but speculation. That would not diminish its significance. A silent passage would mean that an object displaying engineered behaviour entered the solar system, executed perfect alignment and activation sequences, and then simply left. That alone would mark a turning point in how we understand what may be passing through this star system without fanfare, without noise, and without asking permission. The third unknown is more troubling. If something does change, if it deploys subprobes, alters its orbit, or vanishes entirely, we may not recognise it immediately. The emergence may not be cinematic or dramatic. It may be quiet, a shift of a few kilometres, a subtle mass reduction, a faint dot appearing where none was before. The scale of what may unfold does not favour spectacle, it favours subtlety, the kind designed to slip beneath the threshold of human attention. The fourth unknown is the nature of what it is, or what it belongs to. If 3i Atlas is a probe, its origin is likely older than our species. It could have been launched long before Earth was industrialised, perhaps even before humanity existed. It may not be targeting us, watching us, or reacting to us at all. It may simply be continuing a task it began centuries or millennia ago, a piece of an interstellar architecture too large and slow for our short-lived perspective to grasp. That leads to the fifth and most difficult unknown, whether this is the first. There is no reason to believe that 3i Atlas is unique. If an object like this can enter the solar system on a precise low inclination trajectory, then others may have done so before. Others may already be here. Some may have passed through unnoticed in the centuries before we built the instruments to see them. Some may still be here, buried in the background noise of orbital clutter, unlit, unseen, and waiting. This idea is not comforting, but it is plausible. The Fermi paradox does not necessarily point to emptiness. It can just as easily point to a galaxy filled with silent watchers, none of which ever intended to speak. We may not be confronting an arrival. We may be finally noticing something that was always here. The sixth unknown is what governments and institutions will do if anything emerges from perihelion. Silence has been their strategy up to this point, and it has worked. The public remains unaware of how extraordinary this object's pre-perihelion behaviour truly was. But a deployment event, even a small one, would force a response. Whether that response is open disclosure, careful obfuscation, or continued containment remains unclear. The answer may shape public trust in ways that ripple far beyond astronomy. The seventh unknown is the timeline. If subprobes were deployed during the blackout, detection may not happen quickly. Days, weeks, months could pass before small objects are noticed, if they're noticed at all. They could drift silently in heliocentric orbits, blending into statistical noise, waiting for our instruments to evolve or for their own silent schedules to unfold. It is entirely possible that the most important moment of this story won't be October 29th or even December. It may be years later, when something unexpected is found in orbit and someone quietly traces its path back to a moment we couldn't see. The eighth unknown is intention. Even if 3i Atlas is an artificial object, what it is meant to do remains opaque. A probe does not need to be hostile to be unsettling. A watcher can be indifferent. A seed can wait. If this object belongs to a network of autonomous machines seeded across star systems, its behaviour might be governed by rules that have nothing to do with us. It may simply be acting out a program written before humanity ever lifted its eyes to the sky. This is why the tone among those who understand the full scope of its anomalies has grown quieter, not louder. The more they see, the less they claim to know. And perhaps that is the most honest response to something like this. And then, centuries from now, when we are something else or nothing at all, Another civilization might look up, notice a strange object near their star, and ask the same questions. It is entirely possible this story isn't unique to us. It may be a recurring note in a much older song. For now, the skies remain bright and silent. The sun hides what may be unfolding, and humanity stands on the edge of an event it cannot fully perceive, caught between data and myth, science and unease. The truth will not arrive with trumpets. It will arrive slowly, in background noise and telemetry spreadsheets, in the quiet hum of observatories as they search the December sky. A faint dot may return, or many may, or none. 3i Atlas has not spoken a single word, but its trajectory has, and it has said with quiet precision, "I was here." Whether you are ready or not is irrelevant. And then, centuries from now, when we're something else or nothing at all, another civilization might look up, notice a strange object near their star, and ask the same questions. It is entirely possible this story isn't unique to us. It may be a recurring note in a much older song. For now, the skies remain bright and silent. The sun hides what may be unfolding, and humanity stands on the edge of an event it cannot fully perceive, caught between data and myth, science and unease. The truth will not arrive with trumpets. It will arrive slowly in background noise, in telemetry spreadsheets, in the quiet hum of observatories as they search the December sky. A faint dot may return, or many may, or none. 3. Atlas has not spoken a single word, but its trajectory has, and it has said, with quiet precision, "I was here." Whether you are ready or not is irrelevant.